Hi, welcome to the fun probability problem solving sessions. And today we're going to solve the problem is like a point. So it says a point Q lies in the interval 0, 1. Suppose that the distance 0 and Q is a lowercase q. Then a point is randomly selected from the 0, 1, dividing the line into two segments. What is the expected length of the segments that contains Q's here? Okay, so let's go ahead get a start. So let me go to the whiteboards here. Okay, so before I show you how to do the general formula, let's take a look some special case. Maybe that will make sense. And in here, for this problem, the key things we're going to use is the property for the uniform distribution. Okay. Okay, so for the uniform distributions here, so if you have x random variable is uniform in the AB, all right, so in the segments AB, then we know the expected value, that means the mean value of the x for the uniform distribution will be a plus b over 2. Okay, so this is the property we're going to use for this problem here. Okay, before we derive the general problems here, let's take a look at some special examples so that will kind of make sense here. All right, so let's take a look. This is 0, 1 here. All right, so let's assume my point Q. This is my point Q is at the 1/3, the point here. All right, so it is at the 1/3. Okay, so now like now I have a point x, right? So it's randomly false here. So let's say here, if the random variable x randomly falling in this segments here. Okay, so let's assume the x. So let's take a look at this because the x have equal chance to fall everywhere, right? So let's take a look. The x is a uniform distributions in these segments here. So based on my a while ago we say if x is the, so let we say if so the here, so if x and point as false between 0 and 1/3, right? Then we know the expected value of x, because this is uniform, so will be 1/2 a plus b. So it's 0 plus 1/3. So what is here is 1/6. Okay, so that means in here, this will be right at the center, right? So this is will be 1/6. This will be the expected length, expected value. So that means from 0 to here is 1/6. But in here, we need to be very careful because the problem asks what is the expected length involved containing Q. So if the x falling in the range from 0 to 1/3, so the expected value here is 1/6. So its distance is from here is 1/6. But the constant we are looking at is the segment including the Q. So we are looking for what? So the expected length, the segments, the involves Q will be 1 minus 1/6 is equal to the 5/6, right? So that's basically telling you here, that means this is the expected length, right? Okay, so it's 1/6. Okay, so now let's take a look at the second situation here. Okay, so let's still use this example. This is 0, 1, and my Q is on the 1/3. So this is my Q. How about my X is randomly fall in here, right? So in this segment here. So if the X is fall in this segment here, so let's see here. So if X falls between 1/3 and 1. That means now we are looking for the uniform distribution for this area, this segments, right? Okay, so now what is the expected value for here? So the expected value will be the same, is 1/2 and 1/3 plus 1. So what is that? Is 2/3. Okay, so now I know here, this one's here, this point here, this will be what? This is 2/3, and this will be my expected values here for this segments here. And so the 2/3, because this point is for here, right? So this segments is the one including the what? The Q. So this one's here is the expected length for this segments here. So it's a 2/3. Right? So now I know, if you fall in here, the expected length is 5/6. If you fall in here, the expected length will be 2/3. But what is the chance? So what is the chance I'm going to fall in between 0 and 1/3? So it's 1/3 of the chance, right? So I know it's 1/3 of the chance. Then what is my expected length? Is 5/6. Then plus, what is the chance for the second situation? You're going to have 2/3 of the chance, right? Then times 2/3. So this is the expected length for the segments here. So then here you got the total is 13/18. So it's approximately to the 0.72. All right, so that's kind of reasonable, right? Because the axis should have more chance to fall in here, so the expected length will be bigger than the 0.5. If they have a half and half, so it will be 0.5, right? The fall in between the 0 and the 1. So for this example, it's kind of like makes sense. So the expected length will be about 0.72. Okay, so now let's use this concept. So let's derive our formulas here. So in here, the expected length here, right? So let's take a look at situation number 1 here. I'm going to have 1/3 of the chances. So I have 2 chances here. And now what is the expected length? Because remember here, so now if you put it into the general situations here, so let's see here. So if this is the general situations, right? So let's try to put here. So this is a Q, right? So this probability is a Q. So I know if you fall in here, right? So the expected is what? The expected value will be what? Is a Q/2. But remember, for the case number 1, we are looking here, right? So expected value is 1 minus Q/2. So this will be equal to the 1 minus Q/2. So this is our first situation. Then plus the situations here for the second one, so it's 1 minus Q times here. So like, let's see the case number 2 here, right? So this is my point Q. So this is the probabilities Q's here. So I know for anything I go over here, what is the what is the expected value? The expected value will be 1/2 1 plus q, right? Because the the 1/2 plus q's here, because this is the 1 and this is the q's, right? So it's 1/2 plus q. And now, because I'm on this segment, so my expected length for this situation is just here. So it equal to the 1 plus q over 2. So you times 1 plus q over 2 here, right? So that is the overall. Then like if you simplify it a little bit, so it's q minus q squared over 2 plus 1/2 1 minus q squared. All right. So then you will be equal to so this will be, 1 minus q squared here. So I'm sorry, this is a plus, right? So this is a q minus 2q squared plus 1/2 minus q squared over 2. So the final answer will be 1/2 plus q and minus q squared over 2. See here. Right, so you can check to see you did it correct or not. So if you put the q equal to 1/3, so if you substitute the q equal to the 1/3, it should give you the same answers here. All right, so this one's here basically try to test your concept about the about the uniform distributions, right? So the problem can change. Instead of say the ones, the 0 to 1s, right? So they can give you a segments here. So they can change that problem to like this is A to B, and then you have a Q here, and then they will say, okay, the probability here is a Q here, right? Then what is the expected length? So it will be the same thing. You just instead of the A, instead of 0, you have A. Instead of the 1, you have B here, right? So that's what that's what will make the problem a little bit more complicated later. Okay, so like expected value, if you fall in here, and then because this is the probability Q's here, right? So then you need to see what is this values here. So you will find the mean value. But it will make the problem a little bit more tedious, but the concept is the same. All right, that's it. So hope you enjoyed how to solve this problem. It's very neat problems here, okay? Talk to you later. Bye-bye.